Matter around us. Hello children, warm welcome to an interesting session of digital classes. Now let us discuss matter around us. By the end of this class, you will be able to explain the states of matter, identify the shape and volume of solids, liquids and gases, list out the characteristics of particles of matter, explain the diffusion of states of matter. Particles of matter have space between them. Children, observe matter around us. See the pictures. Gold metal, metal coins, iron rod, carbon, sulfur, sulfuric acid, calcium hydroxide. Introduction. Children, do you know all the metals and non-metals, synthetic and natural materials, acids and bases are the examples of matter. Water we drink, food we eat, air we breathe, clothes and various things that we use in our daily life are the examples of matter. According to ancient philosophers, every matter is made up of 5 basic elements. They are air, earth, sky, water and fire. These are called Panchatattva. Sky, fire, air, earth, water, all these together are called Panchatattva. Now let us discuss the matter. Everything around us is made up of matter. All the things around us which exist in variety of shapes, sizes and texture is matter. That means the things around us, chalk piece, table, blackboard, chair, whatever it may be, the things around us, they have variety of shapes, sizes and texture is matter. According to modern science, let us define the matter. Anything which occupies space and has mass is called matter. Children, observe the forms of water. Ice, water, water vapor. Children, what we can observe from these pictures? Ice is a solid, water is liquid, water vapor is gas. Now let us discuss states of matter. Matter exists in 3 states. They are solids, liquids and gases. Water can be found in these 3 states: ice as solid, water as liquid and water vapor as gas. Thus we can say that solids, liquids and gases are 3 different states of matter. Now let us discuss the properties of solids, liquids and gases. Property: solids, liquids, gases. Shape: solids have fixed shape, liquids have shape of the container, gases no fixed shape. Volume: solids have fixed volume, liquids have fixed volume, gases have no fixed volume. Compressibility: solids have very low compressible, liquids low compressible, gases are highly compressible. Diffusion: solids undergo diffusion very slowly, liquids undergo slow diffusion, gases undergo diffuse very freely. Arrangement of the particles: in solids the arrangement of particles are very closely, in liquids arrangement of particles are slightly loosely, in gases arrangement of the particles very freely. Example: children, can you give the examples of solids? Stone, wood, chalk, iron rod, ice. Can you give the examples of liquids? Water, oil, milk, petrol. Can you give the examples of gases? Water vapor, oxygen, nitrogen. These are the examples of solids, liquids and gases. Children, observe the image. These are the some articles which are arranged in the picture. Can you classify the articles are solids, liquids and gases? In this picture, dictionary, ball and scissor are solids, water in a beaker is liquid, coconut oil is a liquid, air in a balloon is gas. Children, let us perform an interesting activity to observe the shape and volume of solids. Take 3 different containers: glass beaker, steel vessel, plastic container. Take a rubber cork, put the rubber cork into a glass beaker, take it out the rubber cork in a steel vessel, take the same rubber cork, put in a plastic container. Observe the changes in the rubber cork. Children, is there any change in shape and volume of rubber cork? Observation. From this activity, the shape and volume of rubber cork remain same in all three different containers. Learning. From this activity, we learn that solids have definite shape and fixed volume. Children, let us perform an interesting activity identifying the shape and volume of liquids. Take three different containers: glass beaker, conical flask and measuring jar. Pour some water in a glass beaker. Same amount of water is taken in a conical flask. Same amount of water taken in a cylindrical jar. Mark the level of the water in a glass beaker. Mark the level of the water in a conical flask. Mark the level of the water in a cylindrical jar. The water occupies the shape of the glass beaker. Water occupies the shape of the conical flask. Water occupies the shape of the cylindrical jar. In this activity, we observe that liquids take different shapes based on the container, whereas the volume remains the same. Learning. We learn that liquids have no fixed shape but have a fixed volume, and also liquids can flow easily from one container to another container. So, liquids are also called fluids. Now, let us observe the shape and volume of gases. Gases will not have fixed shape and volume. For example, compressed natural gas CNG. Natural gas is compressed at high pressure, which is used as fuel. CNG and all other gases neither have fixed shape nor volume. Children, observe the picture. CNG fuel filling in a vehicle, CNG cylinder in a car. Children, let us perform activity compressibility of different materials. Take a 10 ml of syringe, draw the piston, suck into the air, place the finger on the nozzle, press the piston and observe the depth of the piston moves into the syringe. Repeat the same process with water and sand. Draw the piston, put the finger on the nozzle and press the piston and observe the depth of the syringe. Repeat the same process with sand. Children, observe the depth of the syringe. Observation. From this observation, we find that gases are highly compressible as compared to solids and liquids. Learning. Mostly gases are used for cooking, liquefied petroleum gas and in many automobiles. In all these purposes, large volume is compressed into cylinders of smaller volume to make them portable. Children, observe the picture. These are the cylinders which are used in our daily life for cooking food. Now, let us discuss the characteristics of particles of matter. The particles of matter are very, very small. The particles of matter have space between them. The particles of matter undergo diffusion. The particles of matter changes from one state to another state. Let us discuss the diffusion of matter. The intermixing of particles of two or more substances on their own is called diffusion. Examples of diffusion: smoke from incense stick, vapors of scent, smell of naphthalene balls, diffusion of carbon dioxide and oxygen. Children, let us perform an activity to observe the diffusion of gases. Take incense stick, light the incense stick, place the incense stick at the room of the corner and observe the changes. Observation. In this activity, we observe that when we light the incense stick, the scent in the vapor form and smoke mixes with the air and moves across the room to reach our nose. Learning. From this activity, we learn that the movement of air vapors of scent and smoke is known as diffusion. In this case, smoke, vapors of scent and air are highly mobile and are in the form of gases. Let us discuss an interesting activity observing the diffusion of solids and liquids. Take two beakers, pour some water in it, pour some water in a second beaker, take potassium permanganate crystals. With the help of spatula, very little amount of potassium permanganate crystals added to the first beaker and observe the changes. Take KMnO4 solution with the help of dropper. Add 1 or 2 drops into the second beaker and observe the changes. Observation. In this activity, we observe that the particles of potassium permanganate crystals and potassium permanganate solution mix up with water on their own. Learning. We learn that the particles of potassium permanganate crystals and potassium permanganate solution diffuse in water. Let us discuss the applications of diffusion. Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of aquatic animals and plants. During respiration, oxygen diffuses from lungs into blood. Carbon dioxide diffuses from blood into lungs. Children, let us perform an activity to observe the speed of diffusion of two gases. Take a narrow glass tube, 2 rubber corks, ammonia solution, HCl acid, cotton plugs, 2 watch glasses. Take ammonia solution in a watch glass, dip the cotton plug into the ammonia solution, insert to the one end of the narrow glass tube, fix the rubber cork. Take another cotton plug, dip in the HCl solution, insert the other end of the narrow glass tube and fix the rubber cork. After few minutes, we observe a white ring is formed. Children, are you observe the white ring? Observation. We observe that the formation of a white ring from a least distance of piece of cotton with HCl acid. Because of the hydrochloric acid gives off hydrogen chloride gas and ammonia solution gives off ammonia gas. Children, observe the white ring. Learning. From this activity, we learn that both gases react together to form a white substance called ammonium chloride. Children, observe the picture. Solid, liquid, gas. In solid, the arrangement of the particles have less space. In liquids, the particles have more space. In gases, the particles have huge space. Now let us discuss how diffusion takes place. Particles of solids, liquids and gases can diffuse into liquids and gases. The rate of diffusion of liquid is higher than solids. Let us discuss how diffusion takes place. There are two reasons for high rate of diffusion of gases. 1. Due to higher speed of gas particles. 2. Greater space between the gas particles. Let us discuss Can matter change its state? You must have seen many other materials that can exist in different states. For example, coconut oil is usually liquid, but on cooling it becomes solid. Camphor is solid, but if we leave it in the open air for some time, it directly changes into gas. Solid substance directly change into gaseous state. This process is called sublimation. Example: naphthalene balls, camphor, ammonium chloride crystals. Solids, liquids and gases are different states of matter, but the properties of matter are different in different states. This is because all matter is made up of very tiny particles. Children, let us perform an activity. How small the particles of matter? Take 4 glass beakers. Potassium permanganate crystals. To prepare potassium permanganate solution, add some water into the beaker. With the help of spatula, very little amount of potassium permanganate crystals are added to the beaker. Potassium permanganate solution. Take measuring jar of 10 ml. Add 10 ml of potassium permanganate in a measuring jar. Take 90 ml of water into a measuring jar. Add 90 ml of water into the beaker. Take the 10 ml of KMnO solution from the first beaker. Take 90 ml of water in a measuring jar into the another beaker. Add KMnO4 solution to the second beaker and observe the changes. Take 10 ml of KMnO4 from the third beaker. Add 90 ml of water into the fourth beaker. Take 10 ml of potassium permanganate solution, add to the fourth beaker and observe the changes. First beaker of potassium permanganate solution, second beaker of potassium permanganate solution, third beaker of solution, fourth beaker of potassium permanganate solution. Observe the changes. Observation. From this activity, we observe that the solution remains colored even highly diluted, but the intensity of the color of the solution decreases with dilution. Learning. From this activity, we say that several tiny particles in very little crystals of potassium permanganate which gets uniformly distributed in water. Let us perform an activity. There exists space between the particles. Take a glass beaker. Add 200 ml of water into the beaker. Mark the level of the water in a beaker. Add sugar crystals with the help of spoon to the beaker containing water. Stir with the spoon and observe the changes. All the sugar crystals are completely dissolved in water. Now observe the level of the water in a beaker. Observation. We observe that the level of the water in the beaker is at the same mark where the water level was initially in the beaker after dissolving the sugar in a beaker. From this activity, we conclude that liquid particles in a liquid have some space between them and solid particles enter into the space between liquid particles on dissolving solid in liquid. Improve your learning. Give the examples that the matter which will be available in different states. Second one, compare the properties of solids, liquids and gases. Third, mention the situation where we use diffusion in our day-to-day life. 4. How do you prove that the speed of diffusion of ammonia is more than that of speed of diffusion of hydrochloric acid? For better understanding of the concepts, solve the worksheets. Please visit the official website SIET for worksheets. Thank you.